In this video, we're going to review how to create and use a standard curve in Excel. Two things you're going to want to have open are your Excel app on your iPad, and you want to have your folder open to the page where it says how to create a standard curve in Excel. Once you have those two things, first step on this is to collect your X data and your Y data. This is something that you would either do on the lab side or this data could be provided to you. Once you have that, then we can get started on opening up a blank workbook. In order to do that, we're gonna tap on the plus icon here. Tap on this first one, and now we have a blank workbook. If you get to this step and you're unable to edit your Excel sheet, make sure you're signed into your EUHSD account. Otherwise, you're gonna have trouble moving forward from here. Next thing that you're gonna do is we're gonna add our titles with our units. So we're going to use the example that's in this guide just to practice creating a standard curve graph. So I'm going to type in my titles, which are 4-finger length, inches. And what you want to do whenever you create these titles for your data, you want to make sure you include those units. Some measurements that you will take do not include units, so make sure you're paying attention to that. If you notice, my title here goes past the cell. So in order for this to not get cut off, I can do a couple things. I can either tap on the A and manually resize this, or what I can do is tap on the cell that has the text, go to these 3 bars next to the A, and then tap wrap text, and then it automatically reformats the text so it fits in this cell. I'm going to add my other title, foot size, inches. And again, you can tap on this, tap on the 3 lines, wrap text, and it automatically makes it fit into the cell. Then I'm going to put in my data from the how-to sheet that we have here. Oops, that's a 13. All right. So now we got all our data typed in, we have our titles with our units, now we're ready to move forward from here. So once you have your titles with units, your data, then we can add a scatter plot. What we're going to want to do is we want to select our data and our titles by dragging our fingers across that information. Then from here, we want to tap on Insert, which is located in the top menu right here. And then from here, we want to tap on Charts. And then we want to, from this menu, from the drop-down menu, we want to choose XY scatter. And we're going to tap on the first scatter plot on the left side. So this is going to be our first scatter plot on the left side. It looks like this. And you can match it up by looking at that picture on your guide. Next, we want to try adding our best fit line, which is going to be our regression equation. And when we do that, we will also be adding our regression line and our R2 value. So in order to do this, we want to make sure that our scatter plot is selected. You'll know it's selected if your screen looks like this. You have your scatter plot and there's these black circles and squares around your graph. And then the upper right corner, you'll see chart is highlighted green. If it's not, it'll look something like this. Your graph doesn't have those black circles and squares around it, and the word chart is not highlighted, instead home is. So make sure you tap on your scatter plot so that you can move forward from here. From here, we're going to tap on layouts. Then we're going to scroll through our options and tap on the graph second to the bottom on the left side. It will have an equation displayed on it. So I'm going to scroll all the way down here. Second to the bottom on the side, it's going to look like this, which it does because it has the equation on it. So that's how I know I'm ready to go. I have my regression equation and my R2 value displayed on my graph. From here, we're going to edit our X and Y axis. If you are missing your X and Y axis, then what you can do is follow the directions in step 5. So you want to make sure that your chart is selected. Then from there, we want to tap on the word elements. And then you want to go to axis titles. You want to make sure both primary horizontal and primary vertical are checked off. And the other thing you want to make sure is checked off is that you have a chart title above your graph. So we want to edit our titles to reflect those measurements with the units. So my x-axis will be 4-finger length, and I also want to include the units in this. And then my y-axis title will be foot size. And again, I'm going to include my units. So notice that matches up with my data table. So my A column essentially becomes my x-axis, my B column becomes my y-axis. And then the title at the top of your table, we want to make this more specific to include both our x-axis and our y-axis. So for this, we would have 4-finger length. You can include the units in here as well. Versus foot size in inches. When you do this standard curve graph for your performance task, you'll have two things that you're comparing, your concentration and your absorbance. You want to include that title and to be a little bit more specific to include what solution you are testing and the maximum wavelength as well. So for example, for the Kool-Aid mix, it could be something like concentration versus absorbance of Kool-Aid mix at 505 nanometers as an example. So just make sure your axis titles and your title at the top reflects the data that you collected. From here, what we can do is take a screenshot of your standard curve, and then we can add it into Noteful and then move on to doing the prediction and the calculation. So if I open my Noteful journal, I've already added that standard curve. And again, this is my x-axis and this is my y-axis. Once we've created your standard curve, then what we can do is we can use our standard curve to make predictions for either an x or a y-axis. So if we look at the example that's in Noteful, we are going to predict the 4-finger length. 4-finger length is an x-axis, or an x value, so we don't know what x is, of a scholar with a foot size of 10 inches. Y is foot size, so we know that y is equal to 10. In order to draw our prediction on our graph, we need to start with what we know. So find that value on the either x or y axis. For us, it's going to be y because we know that y is equal to 10. So we start on the y axis, then we're going to draw a line as straight as possible to the regression line. From here, we're going to draw a line going straight down to our x-axis. And this is going to be our estimation. So I'm going to estimate that that's about 3 inches. So I'm going to scroll down here. My foot size that was given to me was 10. And I'm predicting or approximating that I'm going to have 3 inches for the 4-finger length. After you do your prediction, then you can use this here, which is your regression equation, to check your prediction and calculate more accurately what that 4-finger length would be. So let's scroll down a little bit here. In order to use your standard curve to do the calculation, we are going to write the regression equation. So we're going to write the regression equation from our standard curve. So you just take that regression equation and you copy it exactly the same as what is on your standard curve. So y equals okay, here we go. Next, so the next step is to write the known value, plug it into the regression equation, and solve for the unknown. We know that y is equal to 10 because we're predicting the foot size, or we're predicting the forefinger length with somebody with the foot size of 10. From here, we're going to plug in our known value and solve for the unknown. Our unknown is the x. We're solving for x. So in order to solve for the x, we're going to have to do some algebra to rearrange. So how you read this equation is kind of like the y equals mx plus b. We have 10 is equal to 2.9153 times x, so these two numbers are being multiplied, plus 1.3432. So in order to get x by itself, we have to move this over to the other side. Whatever we do to one side, we have to do to the opposite side. Since this number is being added, the opposite would be subtraction. So you have to do the opposite mathematical operation in order to be able to solve for the problem. So if this was instead a subtraction sign, then this would have to be an addition sign in order to move that to the other side. Those two would cancel out. And then let me put this into the calculator. 10 minus... Alright, so from here, we're one step closer to solving for our unknown. But we're not quite there yet. So we have to take it one step further. And remember, these two numbers are being multiplied. So in order to get x by itself, we're actually going to have to divide by this number. And whatever we do to one side, we have to do to both sides. These two numbers are going to cancel out because they're the same. You're left with your x, which is what we want because that's what we're solving for. And then this, we would have to put into the calculator. So 8.6568 divided by 0.9153. So I get my x is equal to super long number. Alright, I'm going to round. So this is pretty big number. I'm going to round to 2 decimal places. So that would mean here. In order to round, I'm going to look at the number right next to it. If it's greater than 5, I'm going to round this 6 up. If it's less than 5, or if it's at 5, I'm going to keep that number the same. Since the number next to the 6 is a 9, which is greater than 5, we can round up. So I'm going to round this to 2.97. and include my unit in this answer, which should be inches. And then let me just fill that in here. We started off with the foot size of 10 inches, and our calculation is showing that this would be about 2.97 inches. And then the last part is looking at our data and seeing if it fits a regression. So for this, we're going to use our R2 value. So our R2 value is this value right here, 0.9949. So that is also provided to you on your standard curve graph. So I'm going to write that down. R2 is 0.9949. Yeah. Second thing you're going to use is this R2 value correlation skill, which should be in your vocab. We're going to use those two things to look at our data and see how well does this data fit our regression. If you look at this number, this is right in between strong, and it's very, very close to perfect. So I'm going to write down an explanation for this. So, oops. Go back here. Okay. So I'm going to say our data fits the regression. And here we can say either very strongly or almost perfectly because it's in between the two. Our data fits the regression almost perfectly. So our data fits the regression almost perfectly because our R2 value is 0.9949. This shows that our data is reliable. So the closer your R2 value is to 1, the more reliable your data is because it better fits the regression. The closer it is to 0, the less reliable your data is because the less those data points fit the regression, meaning those data points are going to be all over the place on your graph. Which makes sense because if we look at our graph, all of those points are pretty much on that regression line. So that's it. That's how you use your standard curve graph to predict and calculate an unknown. Good luck on your performance task.